Okay, here we go for today, guys. Complex unit rates and ratios. All right, for complex unit rates and ratios, we are going to be working with ratios and rates to answer our problem. So every problem you need to do, you need to set up as a ratio in order to solve. Okay, there are other ways of solving these problems, but this is the skill I want you guys to practice on. So in our first example, we have Arthur mows 2/3 of his lawn in 1/4 of an hour. How much time does it take to mow his whole lawn? So it says, how much time does it take to mow his whole lawn? So we want to mow one lawn. So we actually want the 2/3 in the denominator because we want to know time compared to the lawn. So the time is 1/4. There's our ratio, 1/4 to 2/3. Okay, our time compared to our lawns. Okay, how much time will it take to mow his whole lawn, time to lawns. So that's 1/4 of an hour to do 2/3 of the lawn. So if we continue this ratio until we have a denominator of 1 is what we're trying to get to. Now 2/3 is not going to 1 easily. So how do we answer this problem mathematically? Well, in order to answer this problem, all we are going to do is look at this fraction bar here and think what a fraction bar means. We have 1/4, fraction bar 2/3. Well, if I gave you 4, fraction bar 2, you would do 4 divided by 2. The same is going to be true here. This really stands for 1/4 divided by 2/3. Now I can turn that into a multiplication problem to solve it. 1/4 times 3/2. When you get that, you're going to get 3/8. Okay? So, how much time is it going to take? Well, he's going to get 3/8 of his lawn done. He's going to, in 3/8 of an hour. Okay? He's going to get 1 lawn done. That's our ratio. So how long is it going to take him to mow? 3/8 of an hour. Okay? So again, we're looking at it, how much time it takes him to mow his lawn. So time compared to his lawn. So that's why it's 1/4 over 2/3. That really is a division problem. So then we're going to look back to our last chapter on dividing fractions and work through that. Okay, so it'll take 3/8 of an hour to mow his lawn. I didn't ask for that in minutes. We could convert minutes later, but we're not going to do that now. In example 2, let's say Kaylin used 4/5 of a bag of chocolates to make 4 batches of cookies. How much of a bag of chocolates do you need for 1 batch of cookies? So this time it's bag of chocolates on top compared to 1 batch of cookies. So we want to find out our 1 batch of cookies. So if we think of our unit rates, it's going to be the batch of cookies is in the denominator. So this problem is going to be 4/5 is our numerator of our ratio. The denominator is going to be our 4. Okay, bag of chocolates compared to batches of cookies. So to solve this problem, again, we have a division problem. So that's going to be 4/5 divided by 4, or 4 over 1. We write that as multiplication. That's going to be 4/5 times 1 over 4. I can cross cancel those. So that's going to be 1/5. Okay, so how much of a bag of chocolates do you need for 1 batch of cookies? He needs 1/5 of a bag of chocolates. Okay? So again, you have to look at what the problem is asking for in order to solve it. In this case, I want to know bags of chocolates compared to 1 batch of cookies. That's why the batch of cookies was on the bottom and the bag of chocolates was on the top. Okay? Alright, and I'm going to switch pages to my next example. In my last example, example 3, a recipe calls for 1½ cups of butter, 4 eggs, and 3/4 teaspoon baking soda. So, you got to read the question, know what order to go in. How many cups of butter are needed for each egg? So, butter is going to be in our numerator, it's first, eggs is going to be in the denominator. So that's going to be 1½ over 4. Okay, butter's on top, eggs are on the bottom. So now what I'm going to do is I'm going to solve this problem by dividing. So I'm going to do 1½ which is 3/2. I'm just going to go ahead and convert them. Divided by 4 over 1. So 3/2 is my 1½ divided by 4. That turns into 3/2 times 1 over 4. And again, I'm going to get 3/8. So how many cups of butter are needed for each egg? You need 3/8 cups of butter. Okay, and there's my answer. So again, cups of butter goes on top for each egg. There's my unit rate comes in because it's per 1 egg. That's going to be our denominator. So eggs are on the bottom. Okay, let's keep the answer up there. How many teaspoons of baking soda are needed for 1 cup of butter? So we have baking soda is going to be on the top, so that's 3/4. It's going to go on the top of my ratio. The denominator of my ratio is going to be our cups of butter in the problem, 1.5. Okay? Now, some of you might see what that is, but we're going to go through our work just to find out what our answer is. So, in order to do this, we're going to do 3/4 divided by, again, I'm going to do 3/2. Turn it to multiplication, 3/4 times 2/3. I can cross cancel. The 3's will become 1. This 2 becomes a 1, and that 4 becomes a 2. Multiply across, I get 1/2. So how many teaspoons of baking soda are needed for each cup of butter? Well, I need 1/2 teaspoon of baking soda. Oops, put it there. Of baking soda for every cup of butter I put in there. Okay. Now the importance of this would be if I wanted to change my recipe around. Okay. So if I needed to adapt it, I would need to know how to do this if it's not an easy just doubling or something. So you can do this in problems, and you could use these ratios to help figure out if you need it. So let's say you're cooking, for example, and you had 6 eggs and you wanted to use all of them. You could set up a ratio like this for 6 eggs, and then you could figure out how much of the other stuff you need to keep the recipe at the same rate of ingredients that you're putting in there. Okay? That is it for today. As you can see, it's a blank page down there. So that is it for today. Have a wonderful night, and we'll practice some complex unit rates and ratios tomorrow in class.